When I first arrived at Daisybrand, the testing was being done after the product changes were made with ad hoc testing. The first thing I did was to implement some structure to the testing by creating this template to capture test case information and result metrics. There are several templates broken down by application. For example, this is for the logistics planning application. It is designed to allow a user to copy it to a results directory and begin running the test cases. First, the tester inputs initial information about this particular test run. Each column serves a special purpose. The test ID column allows us to have a test identifier which can be used for traceability to requirements or automated test data. The module column displays which area of the application is being tested, which allows the tester to prioritize the test run based on where the changes were made or other risk-based assessments. The description column is used as a quick indicator of what is being tested and some data being used. The procedure column contains the steps the tester should take to complete the test case, and the expected results gives the tester a clear indication of when the test is done. The rest of the columns are self-explanatory. Each test is independent of other tests, so when prioritization happens, there is no need for the tester to decipher which tests must stay together, and it also allows automation to mirror this format easily. The test summary tab shows many metrics with a pie chart, has made management very happy with the new visibility of QA results. I am the test lead at Daisybrand, so I trained the existing QA testers on these procedures and had them begin writing the smoke tests as a first step to getting the QA department the much needed structure. HP's Quick Test Pro was the tool purchased by Daisybrand, since it was the one that recognized objects best, which were created with DeveloperExpress.net package that was being used for application development. Here in this QTP screenshot, you can see I have used the same numbering system as I did with the manual test cases. Automated testing is simplified for ease of updating and running when data is separated and pulled from an outside source. On the lower part of this screen, you will see how this is done in an Excel spreadsheet. I will now walk through a demo test case and some of the thought that went behind its creation. QTP uses VBScript, and most code is encapsulated in QTP's actions, which are referenced in the script and are similar to methods or functions in standard programming languages. On line 2, in the VBScript, you can see a call to an action which gets all test data from the Excel spreadsheet and uses the column name as a variable name to hold all data needed for that test case. Line 3 in the script runs a setup routine for the TruckDock application to verify it is in the same state every time a script is run against it. Line 4 and 5 exercise the application's functionality. Lines 7 and 8 verify information on the TruckDock user interface contain expected trading partner values, which are also referenced in the Excel spreadsheet below. After the smoke test automation was underway, I tackled the need to control the execution and results of the developed automated test cases. Unfortunately, the tool that comes with Quick Test Pro is very limited and did not meet the needs of the QA department at Daisybrand. So I got the opportunity to build an in-house HTML application to fulfill this requirement. Here you see what I have labeled the Quick Test Pro script runner. In the script runner table, I have used VBScript code to pull information from the Excel spreadsheet on the previous screen and verify their existence in the directory structure you see at the bottom of the screen, giving the user the options to run all test cases, include multiple test runs specified in the Excel spreadsheet, or just a suite that is associated with a particular application under test. The script also uses an algorithm to calculate the approximate run time displayed on the buttons themselves. The text area below allows the user to select one or multiple scripts to run in succession by clicking the Run All Selected button. Once one of the buttons are clicked, the HTML underneath calls functions I have written in VBScript, which uses the QuickTest Pro APIs to run the requested scripts and build an HTML results file in a date timestamp directory structure. Finally, the results viewer is the view of the results structure that turns each results file into a link, which can be clicked to reveal the results that were created from the test suite run. Here you see the results that were built as each test case was running and a link to the QTP results as seen through the QTP results viewer. And a link to the QTP HTML detailed results in case the user does not have the QTP results viewer installed. This is an application built with the testing tool QuickTest Pro, which was a result of the development manager of Daisybrand coming to me and asking if I could get QTP to interact with an Excel add-in which was designed to pull data from an offsite Nielsen database and to then turn around and input the data into our own internal database. After several meetings with marketing to get the exact requirements and understand as much of the Nielsen software that I needed, this is what I developed. I will quickly go through what it does from a code point of view. Near the top you can see I have added the different types of products and reports that marketing requested. For example, sour cream market and cottage cheese account. This was put into a VBScript collection object which also associated the product with the name of the template which is used to run the database pool. This is put at the top of the script and clearly defined to make it easy for the marketing department to add additional data pools to the script as needed. Also, I have set up 4 arrays which are used to keep count of each report's status as it is uncovered by the script. Moving down the script, we see verifications that all mandatory test components are in place, so we can quit the script early if something is missing and the script is not able to run to completion. First, the script verifies that the database is accessible by running a quick, simple query to verify something is returned. If the database is not available, the script exits and sends an email to all stakeholders informing them of this issue. Second, the script verifies that each template that the data is to be pulled for is available. Each template that is not available is removed from the products collection and the test is failed with this information documented. Next, after it is established that all mandatory components are in place, each product is ran through a series of steps to determine how the report should be treated using a for each loop to process each of the products collection which was defined earlier in the script. After some initial processing to get the report ready to run, the script is ready to begin processing the data. An additional nested for loop is created so each target date for the data pool is ran for each product type. First, a file not checked flag is set to true, which will later tell the script whether or not the database and the Excel file are synchronized. Next, the first report is ran using dates from existing templates which are customized for each report. Then, there is a quick check of the database to figure out if the particular data for this product is already present. If this data is new, it is put into the database at this time. Then the name of the Excel file is pushed on to the array called Array Selections New, so detailed results can later be emailed to stakeholders. However, if the data is already present in the database, the VB script then goes a step further to verify if the data is the same by comparing a row total of the source Excel file to the equivalent row total in the database. If the totals do not match, the old data in the database is cleared and the new data is put in its place. Also, the Excel file name is pushed to the array selections updated for email result purposes. If the totals do match, we know that we have a database that is up to date and no processing is necessary, and that we have synchronized the database and the Excel file. After that, using the File Not Checked flag, we verify synchronization of the database and the Excel file for any source Excel files that were not previously verified. If by this point things are not synchronized, there is a problem which needs to be addressed manually, so the XML file name is pushed to the array selections not updated correctly. This ends both of the for loops, which will run again for all the dates and products in the products collection. When all products have gone through the above process, the script contains 4 arrays which hold the results of what happened to each Excel file along the way. An HTML email string is then built which puts each XML file name under an appropriate heading showing the stakeholder recipients what happened during the data pool. The updated email is then sent to the marketing stakeholders and myself. The development manager and the marketing team were very impressed with the quickness at which I developed the script and the stability it has shown in the field. Due to the expensive alternative of gathering this data, it has saved Daisybrand $10,000 and has been used as a model for me to develop other scripts to pull data from various other sources, which has multiplied the return on investment to the Daisybrand company.